Alright, I'm going to be doing a part 1 in a series that's going to go over analyzing WannaCry. This first part is just going to be the simple running of the program. Before you go into static or dynamic analysis, you just want to run the program and see what it does. That'll give you a general idea if there are visual indicators of compromise. Also, it'll allow you to get a general idea of how dangerous the piece of malware is. When you run it in a virtual environment, you'll be able to see what it does, basically. Because if you were to run it on a real environment, and if it's a piece of destructive malware, such as ransomware, like WannaCry, then you're just kind of out of luck when it comes to your files. So here, I went ahead and installed a sample from the GitHub zoo repository. I have my remnux inetsim configuration set up, and I went ahead and unzipped the file. Now, before you run pieces of malware, you do want to make sure that your inetsim configuration, or whatever kind of network spoofing service that you're going to use, works. So first, I'm just going to make sure that this is in host-only mode when it comes to networking. Alright, looks like it is. Let's close that. Now let's go ahead and start inetsim. Alright, now that's running. Now, to confirm that inetsim is running, I'm just going to go ahead and do a simple HTTP request of Google. Let me go to Chrome. And here we can see that the request was resolved by inetsim, which is good. We don't want this to have access to a real DNS server. Basically, we just don't want it to have access to the outside internet. As far as this computer knows, this is the network it's confined to. All DNS queries, all HTTP requests to websites will be handled by inetsim. Now let's just move this piece of malware to our desktop. Now, we know this is a piece of ransomware, so we know what it's going to do. It's going to encrypt our files, and then it's going to ask us to pay a ransom. Generally, you won't always know what the sample is beforehand, so no. Well, generally, you're not going to know what you're analyzing beforehand. And in this scene in malware nowadays, most of the time it's going to be something like a Bitcoin miner or ransomware, because most malware nowadays is focused with immediate or consumer grade malware or enterprise. It's focused on immediate immediate grabbing of money, basically, whether that be through Bitcoin or banking credentials or Bitcoin mining secretly. So it's always a good idea to make like dummy text files or dummy files that have interesting names like banking info, that kind of thing. So I'll just make like 3. I'll just call this like banking info, because some malware does look for those keywords like banking, passwords, important files. Let's make another one called passwords. We can just call this one SSN. Let's just add some stuff to these files. So let's open it with Notepad. Hello, this is my banking info. My password is password123. And my social security is 1234 WER. Okay, so we have these three very important files on our computer. Now let's just go ahead and actually run the malware. So we're going to add as an administrator. So instantly we see all of these files appearing. Let's go ahead and delete some of these files that are these folders and files that were on our desktop before. Alright, so let's just move them. Okay, these are all of the WannaCry files that were generated. So, just starting off, we can see that a few files were created. Now let's move our original important files over here, and let's just go see if anything was done to them. Okay, we can see that our banking info has been encrypted. So it has our password and our SSN. Okay, well I guess we can consider those files gone. Next, it looks like we have files of our encrypted files, but with the .wncry file extension. Let's go into properties and see what that is, basically. It's a WannaCry file. That's what Windows says it is. Let's go into the details. Nothing much there. Oh, look. It looks like a... Oh. Okay, it also looks like there are these letter files, but whatever those are. It looks like fbcrs.wannacries. Not really sure what those are, but it's worth looking into when I do the static analysis, because those could be important files. There's this n.vbs, which is a Visual Basic script, I believe. Let's go ahead and open that up. Alright, let's go ahead and try and opening these WannaCry files. Let's open it with Notepad++. Just looks like a lot of junk. Yeah, just a lot of junk. What about this Visual Basic script? Alright, this looks like, let's zoom in, set wstrip create object. It looks like it creates some kind of shell object, and then it creates a shortcut for... Okay, so it looks like what this is doing is just basically creating links or shortcuts to these executables, which seem to be @wannadecryptor @.exe, and same thing but a link to that file. And then it saves it. Okay, so that's what that does. Next we have the original WannaCry encryptor. We can move that to the side. We can also move this t.wannacry file, because we know that those are filled with junk. This one as well. And we know that, what is this? This is a bankinginfo.wannacry. Let's see what's in here. Because we know that the original files are encrypted. What about this? Just looks like it says WannaCry. That could be a file signature, perhaps. And then followed by a bunch of encrypted data. This could be a key. Or the something that is used to decrypt our files. Possibly it could be using asymmetric encryption. This could be the public key for this file, and then presumably the attackers have that private key. And once you pay them, they'll, I guess, send you the private key, maybe use it in conjunction with this public key, and that'll decrypt your files. But for the moment, that's what we could guess is what these things are. There is this resource file. Let's see what's in there. Looks like some text and then just a bunch of nulls. PKY. That could be a public key. Let's go see what that is. It does kind of look like some kind of key. Assuming that this is like a hex file, this was just supposed to be a surface level kind of analysis, but we could look at this with a hex editor, like hexd. Look at that, another file just appeared. m.vbs. Okay, some things are happening. Okay, let's just close this. Oh, it looks like, okay, well that tells us something else. It looks like there's a timer that will automatically load these files, this WannaCryptor.exe program. That could possibly be because if a user didn't know that their files were encrypted initially, then I guess they may have set a timer to account for that. Let's see if we can hide this. No, we can't. Let's just move it down here. Now looking back at that hexd, this does look like junk, but no, look at that. If we zoom in, we can see RSA1. This does mean that this does use some kind of public-private asymmetric encryption, because there are references to these RSA1 keys. So this is likely that public key for, this is likely a public key for some kind of encryption/decryption. Whether it's the one for our files is worth looking into. Looks like, that's the res file, and then this is the key file. There are these two exes, I'll save those for later. What is this? It looks like these are the symbolic links for, or no, this is a link for this. And I believe that that's what that is. We can see that by the icon there. Here's a please read me. And if you go through this is just like, oops, all of your files are encrypted. If you want them back, pay us. Yeah. We would decrypt your files, but surely no one would trust us if we cheat users. Right? What is this? This is another WannaCry, but this looks... Okay, it looks like this was a bat file that was on the computer, but now it's been encrypted by the WannaCry ransomware. Here's an EKY and another encrypted file. What is this EKY? Let's open that up with hexd. Looks like this is just junk, but possibly it could be some kind of key file. We're just gonna have to see. And this is another encrypted file. So we're left with these. We know that this is a symbolic link to this, and this is this decryptor program that informs the user what's happened and how you have to pay them. You can see that there are some buttons. Let's go back and see what is this task deal and task.exe. Let's run those as administrator. Looks like nothing much happening. Let's run this one now. Nothing much either. Now it is kind of interesting that when this popped up, there was kind of a warning message in red. Looks like that's what these are. Let's open one up. It's a bitmap, which is an exclusive thing to Windows, or primarily used on Windows. And it looks like a wallpaper to inform the user that their files have been encrypted. If you see this text, if I don't see the WannaCry encryptor, then your antivirus removed it, which would be kind of bad because that means you wouldn't be able to pay them even if you wanted to. If you need your files, run the decryption software. Please run the application file in that. Okay. Oh, it looks like it has a kind of timer, which we can see here, where if the user doesn't interact with it, it likely moves it to the front of the desktop. Here, let's see what happens if I try to close it. Not this. This. Okay, what happens? Let's wait some time and see if it appears again. Yeah, looks that's what happens. Okay, so it looks like this is how much time we have left for this program before I guess it permanently decrypts our files. Here we have a hyperlink about Bitcoin. I assume that makes a web request, but it won't be a result. Let's see. Yeah, it looks like it makes a web request. Oh, it goes to Wikipedia to look up what Bitcoin is. Let's close that. How to buy Bitcoin? I assume that's another web. Yep. So these are links. These are hard-coded links, so when we do our static analysis, we could look for those links, assuming that the program isn't packaged, which it may or may not be. Okay, there's a contact us form. It looks like this does it with the program, so potentially this program is opening some kind of ports, which would be interesting to look at. If we can identify that port, then we can run another instance of this and then see the outbound traffic that the outbound connections that it's attempting to make. Let's see what I'm doing. Fill with junk and then click send. Alright, it looks like nothing happens. Likely because this is a host-only mode, or no, it looks like it froze actually. Let's try and close it. I feel like, yeah, I believe it froze. Load perfmon counters. It's worth looking into that. That would be worth putting into your report and then later looking at it in the static analysis. It looks like perfmon. I believe that is a Windows 32 function, but I would have to check that. Let's click try to restore the program. Okay, nothing much. Let's close the program. Let's try and run it again. Alright, yep, that worked. It is odd that the wallpaper does delete itself. Let's not click that again. It is interesting. It looks like I may have to check the recording, but I believe it kept track of the timer, despite the fact that the program was closed. So there is some kind of persistence. It may be storing that somewhere. Here's the Bitcoin address of the individuals, more data, and then it looks like there's a language packs for different languages. There's Czech, Bulgarian, Russian. Oh, and it allows for zooming in. Alright. Now the last two buttons are these check payment buttons and decrypt. Let's see what this is. Alright, yeah, it looks like it's connecting to a server to see if you've sent the money. That's also worth looking into. Maybe, does it use the same port as the contact us button? Does it use a different port? What kind of traffic is it sending over those ports? Is it encrypted? Does it use TLS? Maybe it uses... maybe it uses a web port, SMTP port. It is worth looking into that. That's not going to get anything. What if we click decrypt? Let's just start. And what's the issue? Okay. So it looks like it lists out the files in our program or in our system. Possibly these are the files that are going to be decrypted. And then it says pay now if you want to decrypt all your files. Likely, based on this, because we have this check payment and then decrypt, what I'm going to guess is that once you make the payment and their internal servers have that in some kind of database, when you click this check payment button, presumably once you've paid, they'll send over some kind of key, or because they technically own your device now, they likely have remote access. They'll install some kind of key or a private key, and then I'm assuming that this decrypt, when you click start, it'll look through the system directories and look for that key. If it doesn't find that key, then I guess it'll send that warning message, but if it does find it, presumably it will decrypt your file, decrypt your files. Let's close that. And it looks like that's really it. We could go into our registry keys, or our registry editor, and see if we can see anything of notes. Given that these are the registry keys, or directories, it is worth looking into when we do our static analysis with strings to see if there are references to those registry directories. Right, yeah, look here. It's even still in Russian, so there is some kind of persistence. Let's see what happens if we try to close it with Task Manager. Also, this is in host-only mode, but we can attempt to run Windows scan on it. Okay, let's first attempt to close it. Here we can see that it uses this load perfmon counters thing, and it is a 32-bit program, which is interesting because this did come out in 2013, so 64-bit would have still been would have been popular then, or would have been the norm for OSs then. Let's end the task. Okay, what happens? Let's see if it pops up on its own again. While that presumably pops up back on its own, we can go ahead and try to run and scan. Yeah, looks like it did. So it looks like there is some kind of background process. I believe for Linux those are cron jobs. I would have to look up again what those are called for Windows. It looks like there's a daemon. I don't know if that's the correct term, but there's some kind of daemon that is checking to see if this is running. Wait, no access. Looks like we don't have access to an antivirus because we're not connected to the internet. What happened if we turn this on? Right. If it looks like we have nothing to do. I could attempt to connect this to the internet, but I don't feel safe doing that, considering I don't want to put my network at risk. So for the moment, I'm going to conclude the initial running of the program. Now we do have a general idea of what it's doing, without even having to look into the PE the PE file format, its headers and sections, and looking into like strings and stuff like that. We have a general idea of what it's doing now. Right, so thank you, and I will now work on the next part of this, which will be the simple static analysis.